Our section 2.3, we're talking about models and applications. Okay, so we're just going to look at linear equations. So to set up or model a linear equation to fit a real-world scenario, the first thing we got to do is figure out the quantities that they give to us, which are called the known quantities, and the quantities that we are trying to find out, which would be the unknown quantities, and we make the unknown quantities the variables. Then what we're going to do is we're going to take the word problem and we're going to change it into a mathematical equation that we can solve. So consider the example here. We've got a car rental agency that charges 10 cents per mile plus a flat fee of $50. We can use these quantities to model the equation, and that can be used to find the daily car rental cost. Okay, so the daily car rental cost is C. And for every mile, so what I'm trying to figure out is the cost. That's the unknown quantity. The known quantity is the mileage, because once I get done using the car, then I will know how many miles I have driven the car. So for every single mile, I have to have 10 cents for that. So you can do 10 plus 10 plus 10 plus 10 plus 10, which is the same thing as 10 times how many you added 10 to itself. So we have 10 cents times x, x being the miles, plus the flat fee of $50. So the cost is equal to, cost or C is equal to 0.10 times x plus 50. Okay, so here's the method of solving these problems. You're going to identify the known quantities, what they give to you, assign a variable to represent the unknown quantities, what you're trying to figure out. If there's more than one unknown quantity, find a way to write the second unknown in terms of the first. We'll have some of those. Write an equation for the word problem that they give you. Solve the equation and make sure the answer that you get makes sense with the situation that is presented to you. Okay, now this is just a reference for you to refer back to. So this is saying that there's keywords and phrases for saying addition, plus more than the sum of the total of increased by added to. All of those are keywords for saying, hey, I need you to add. Equal, they'll either say flat out equals, or is the same as, yields amount to. All of those are the same as, hey, we need an equal sign here. And here's some verbal expressions that go from a verbal expression into math operations. One number exceeds another by a. Well, that's the same thing as x plus a. And usually when you see a number, the number, or something like that, one number, that's usually talking about, just put an x right there. Okay. When they have something like one number is more than another number, well, you'll have x and then another variable. In this case, they use a, so x plus a. So let's look at this right here. Translate the verbal statement to an algebraic equation. The sum of 6 and 9 is 15. Okay, well 6 plus 9 is equal to 15. Okay, twice the difference of x and 3 gives 18. So twice the difference of this whole thing, x and 3, so x minus 3, gives or equals to 18. Okay, 3 times the sum of x and 9 gives 39. Okay, 3 times the whole thing, the sum of x plus 9 gives or equals to 39. Okay, the quotient of a number and 3 is 10. Okay, so quotient is basically saying, hey, it's a fraction of a number, so that's x. So x and 3, that's a quotient, is, so equals 10. Okay, so using a formula to solve real-world applications. So many applications are solved using formulas that we are already aware of. So that includes area, perimeter, and volume. Area is just length times width. Perimeter is 2 times the length plus 2 times the width. And volume is length times width times height. Some applications require us to write a formula for a given situation, okay? But in this case, we would know the formula. So a game room has a perimeter of 70 feet. The length is 5 more than twice the width. How many square feet of the new carpeting should be ordered? Okay, so we've got perimeter is 2 times length plus 2 times width. And they say that the perimeter is 70. And now we've got length and we've got width. We're going to try to get these in terms of x, both of them. The length is 5 more than twice the width. Okay, so I'm going to let width be x. Okay, so 5 more, so that's going to be a plus 5, then twice the width, so 2 times the width. But we said the width is going to be x, so this is going to be 2x. So twice the width and then adding 5. Okay, so 70 is equal to 2 times 2x plus 5 plus 2 times x. So 70 is equal to 4x, and I'm just distributing this 2 to this 2x and to this 5, plus 10 plus 2x. And I'm going to combine like terms. 6x plus 10. Subtract 10 from both sides. So this is going to be 60 is equal to 6x divided by 6. So x is equal to 10. Okay, so that means that x is 10, but this down here is going to be 2 times 10 plus 5. So we got 20 plus 5, or 25. Now it says we're not looking for the length or the width, we're actually looking for the area of the new carpet. And we know that area is length times width. Okay, we found the the width to be 10. Let me do this. We found the length to be 25 and the width to be 10. So the area of the carpet will be 250 square feet. Now the square feet is coming from, we have 25 feet here and 10 feet here. Feet times feet would be feet squared. So this is the area of the carpet that you should order. Find the dimensions of a rectangle given that the perimeter is 110 centimeters and the length is 1 centimeter more than twice the width. Okay, so we've got P equals 2L plus 2W. They said that the perimeter is 110. The length and the width. Okay, the length is 1 more than twice the width. So I'm going to say that x is the width. And then, so twice the width, or x, plus 1. So what we have is 110 is equal to 2 times 2x plus 1 plus 2 times x. So 110 is equal to, distribute this 2 to the 2x and to the 1. So 4x plus 2 plus 2x. So this is going to be 6x plus 2. Subtract 2, so that's going to be 108 and equal to 6x divided by 6 on both sides. So x is going to be equal to 18. Now it said find the dimensions of a rectangle. So the width would be 18, but the length would be 2 times 18 plus 1. So that's going to be 36 plus 1, so 37. Okay, so this would be 37. So the dimensions of the rectangle would be a width of 18 centimeters and a length of 37 centimeters. Okay, find the dimensions of a shipping box given that the length is 4 times the width, the height is 8 inches, and the volume is 1600 inches cubed. Okay, so we are looking for a volume of a box, so length times width times height. They gave us the volume, that is 1600. We need length, we need width, and we need height. Let's see, the length is 4 times the width, so I'm going to say that the width is just x, and then I'm going to write L, or the length, in terms of width, which is now x. So length is 4 times the width, so 4x, and then they say the height is 8. Okay, so then we have 1600 is equal to 4x times x times 8. Okay, so 4 times 8, 32. X times x is x squared. Divide both sides by 32. That will give us 50. Okay, x squared, so I'm going to square root that. I'm going to put a plus or minus in front of that. And side note, we can write the square root of 50 as the square root of 25 times 2, which that would be the square root of 25 times the square root of 2, which that would be 5 times the square root of 2. So this would be plus or minus 5 times the square root of 2 is equal to x. But notice that we're talking about length and width. We're talking about dimensions here, so we wouldn't have the negative. So it would just be the positive 5 square root of 2. Okay, so we would take, so this would be 5 square root of 2. And then this down here would be 4 times 5 square root of 2. So that would be equal to 20 square root of 2. And then there would be your dimensions. The length is 20 square root of 2, the width is 5 square root of 2, and the height is 8. Okay, a truck rental agency offers 2 kinds of plans. So Plan A charges $75 per week plus 10 cents per mile driven. Plan B charges $100 per week plus 5 cents per mile driven. If Tim knows he has to travel 300 miles, which plan should he use? Okay, so let's look at Plan A. Okay, so we're going to say that cost is equal to, let's see, so 75 per week plus 10 cents per mile. So we're going to say miles are our X value. And then Plan B, cost would be $100 per week plus 5 cents per mile. And we know that we have to go 300 miles. So 75 plus 0.10 times 300. Same thing over here. 100 plus 5 cents times 300. And we'll just plug this into our calculator. So this would be 75 plus, this would be 30. So this would give us 105. And over here we'd have, so C equals 100 plus, this would be 15. So this would be 115. Okay, so between the two, looks like Plan A would be cheaper